Welcome back, grade 11 section, and we're talking about acids and bases. Now, let's have a look at this. A concentrated acid. I want to draw a distinction between concentrated acids or concentrated bases and strong acids or strong bases, okay? And weak acids and concentrated weak acids or dilute acids, that distinction there. When we're talking about a concentrated acid solution, we're talking about a solution that is formed when you have got a large quantity of the acid dissolved in a small volume of water. In the same way, if you're talking about a concentrated base, it means you've got a large quantity of the base dissolved in a small volume of water. And what is what we call a dilute acid as opposed to concentrated? In other words, the opposite of a concentrated acid, it's a dilute acid, not a weak acid. A dilute acid is a solution of an acid formed when you have got just a small quantity of the acid dissolved in a large volume of water. In the same way, you can replace the acid part by a base and say a dilute base will be a solution formed when when a small quantity of the acid is dissolved in a large volume of water. Okay. Now, looking at the concentration of a substance, this is found using the formula C equals number of moles over volume. But we know that number of moles is given by mass over molar mass. So we can actually, in place of N, put M over M. When we do that, we end up with this formula here that says concentration is given by mass divided by molar mass times the volume in which the substance is being dissolved. Okay. Now, proceeding, but before we proceed there's something I need to make you aware of. When we're talking acids and bases, we talk of standard solutions. Now, when you work out the concentration of something and you prepare that solution in the lab so that you even know its concentration, we say you have what we call a standard solution. So a standard solution is what? Solution of known concentration. Solution of known concentration. Okay, so that's what we call standard solution. Next, looking at the acids and bases, we've got this theory here which is mostly used, the Lowry-Bronsted theory. In this theory, we define an acid as a proton donor. So it gives protons. It's a proton donor. How do we define a base? A base is defined as a proton acceptor, so it receives protons. What are these protons that we're talking about? The protons we're talking about are the H pluses, the hydrogen ions. We call it a proton because we know hydrogen element number one, once it has lost that electron, all it is left with is that positive charge proton at the center of the nucleus. Okay, now in this case here, for example, you've got HCl gas, which is, we will look at what's happening here, and water. What is happening here is that the H, if you look at what's happening on the right, HCl gives H plus to water to become a Cl minus. And on the other hand, the H2O water receives the H plus to become H3O plus. Okay. Now, when we have this, we have what we call the acid-base conjugate pairs. And which ones do we have here? Here, the HCl is acting as the acid, so it's our acid 1. By giving away protons. It's a proton donor. When it does that, it becomes Cl minus. So this becomes what we call base 1. The two are what we call acid-base conjugate pair. On the same way, here H2O receives the proton. Anything receiving a proton is a base. So this becomes our base 1. On receiving it becomes our base 2. Sorry about that. And on receiving that hydrogen or that proton H+, it becomes H3O+, and this becomes your acid 2. So these two here are acid-base conjugate pair, whilst these ones are also acid-base conjugate pair in that way. All right, now see you in the next section.